Today we want to have a look at how we can find molecular formula of a compound from empirical formula. These are the two important formulae that will be used. So absorb this as we want to start, with some example questions. Now, the first question we want to have a look at is about a hydrocarbon, which is an organic compound containing only carbon and hydrogen as elements, constituent elements. We are given 80% of carbon and 20% of hydrogen in the hydrocarbon. The first question asks us to find the empirical formula of the compound. Now, if you had watched my video on empirical formula, the previous one, you should be able to attempt this question 1. So let me pause the video while you give it a try. Okay, to answer number figure 1, we want to find the empirical formula of the hydrocarbon. The first step is to divide the percentage of each element with its relative atomic mass. Carbon is 80% divided by 12, which is the relative atomic mass of carbon. Hydrogen is 20% divided by its relative atomic mass, which is 1. So what does that give us? 80 divided by 12 gives 6.7, and 20 divided by 1 is still 20. We divide through by the smaller. Divide through by the smaller of the two. That means I'm going to divide through by 6.7, which is obviously smaller than 20. Dividing through by 6.7, I got 1 here, I got 2.99 here. Then we will have to approximate to the nearest whole number. This one will become 3, while this one remains 1. So the empirical formula now will be CH3. That is the empirical formula. 1 atom of carbon and 3 atoms of hydrogen. So that is the result of question 1. Now on to question 2. Figure 2. Don't forget that out of the two formulae I gave, one of these says empirical formula into bracket, then subscript N equals to molecular mass. So what is the empirical formula here now? That is CH3 in bracket N equals to molecular mass given is 30. So we now substitute each of these with their atomic masses. Carbon is 12, hydrogen is 1, multiplied by the subscript 3. So this will be 12 plus 3 times 1, 3, into bracket N equals 30. 3 plus 12 is 15. That will be 15N equals 30. Dividing both sides by 15, N equals 2. So with these two now, we are going to get the molecular formula. Molecular formula now will be CH3 into bracket subscript 2, because N is 2. And that N will these two will affect the two of them. That will be 2 carbon, then 2 times 3, 6 hydrogen. So this is the molecular formula of the compound. That is the actual formula of the compound. In organic chemistry, we call this one ethane. Ethane. That is the name. So let's have a look at another example. This is another question on finding molecular mass or molecular formula rather from empirical formula. This time around, apart from the percentage composition given, we are given vapor density. This time around, we are not given molecular mass, but vapor density. So how do we go about with this vapor density? The first question, the empirical formula. You must, by now, have known how to find empirical formula. If you have not, please go and check my previous video. Even the first example question under this video will guide you through. So I'm going to save a lot of formalities in finding the empirical formula in question figure 1. All right, the first step which I need to mention is that I need to find the percentage composition of oxygen because it is not mentioned in the question. All you need to do is to add up the two percentages together and subtract it from 100. Whatever is left is meant for oxygen. So that is how I got 27.6% for oxygen. So this is the answer to question figure 1. Now, the empirical formula will now be, from this, I have 3 atoms of carbon, 6 atoms of hydrogen, and 1 atom of oxygen. So the empirical formula now will be C3H6O. That is the empirical formula. Now let's go on and find the molecular formula. The first step is to convert vapor density to molecular formula. How? You multiply it by 2. Molecular formula is, to convert it to molecular mass rather. Point of correction. You convert vapor density to molecular mass. How do you do that? You multiply vapor density by 2 because molecular mass 2 times vapor density, and that will give us 2 times 29, that is 58. So I'm going to use the second formula to find N. N is equal to, N is molecular mass over molecular mass of empirical formula. What is the molecular mass of the compound? That's 58. Divided by molecular mass of the empirical formula, 3 carbon, that will be 3 times 12 for carbon, plus 6 times 1 for hydrogen, plus 16 for oxygen. That will give 58, and N equals to 1. Now, using the first formula, that empirical formula into bracket N equals to molecular formula. And since N is 1, that means 1 times everything here will still give you same thing. Therefore, molecular formula is the same as the empirical formula in this case, which is C3H6O. That is pentoxide. So, I will see you in my next video for another topic. See you then.